Professor Bob Young back at you here, and in this part 2 video of rationalizing the denominator, and we will get to rationalizing the numerator. I'm trying to break these videos up so they're not so long on y'all. I know some of you have probably been through, is this video going to ever end? So we will try to make it happen for you. Now remember, rationalizing the denominator removes all radicals from the denominator of a fraction. And in the first video, we went ahead and did some more basic ones. In this one, we're going to have to simplify radicals first in order to rationalize. So in this first example here, the square root of 24, let's go ahead and prime. Remember, that's how we went ahead and wrote things here. I'm going to take this and rewrite it as the square root of 24 would be 8 times 3. So if we broke 8 down into primes, I'm trying to get my 3 in there. It's not working good. All right. Times 3. So 2 to the third power times 3 to the first power times a to the third power. And remember, on a square root, there's a little 2. So we can first look at simplifying radicals. So here's some more review for that. You must be able to simplify radicals both in this course and in future courses. So let's go ahead and circle the wagons down here. How many 2's coming out, 3's coming out, or 3's coming out, and A's coming out? So 2 goes into 3, 1 2 would come out if you remember your simplifying process. The 3's are trapped in the square root. There's not enough of them to get out. They're going, take me with you, 2, take me with you, but they're trapped in the can. 1 2 still trapped in there, all right, because the 2 goes into 3 one time with 1 left. 1A comes out, and 1A stays. So that is how I would tell you to break them down first. Now it's just like we did in that first video. Let's look at the powers here underneath the radical, and since this is a square root, we need 2 of all of those items under the radical, so that will start. You'll start doing these much more quickly. So we're going to multiply both top and bottom of this by the square root of 3 to the first, 2 to the first, a to the first. And if you do it to the bottom, do it to the top. 3 to the first, 2 to the first, a to the first. Now, a lot of people may go, wait a minute, Young, just hold the boat here. What about this 2a? We really don't care about it because it's not a what? Radical. And all we're trying to do, if you look up top, is remove all radicals from the denominator. The 2a is no longer a radical, so it's no longer a threat. So what that gives us, just like the last video, we're going to get the 2a out here. So be careful, don't lose him. Times the square root of 3 squared times 2 squared. Whenever you multiply same bases, add the powers, a squared. And in the top here, here's what we're going to end up with, the square root of, now remember last video, put all of these numbers together here. So I'm going to put some pretty orange in this one. So we're going to multiply in the numerator 5 times 3 times 2 times this a, and that's going to give us 30, the square root of 30a. What do y'all think? The bottom here, that 2a gets multiplied by, remember, the square root will take out one of each one, so you'll have times 3 to the first, times 2 to the first, times a to the first, all over. What's all that multiplied together here? 2a times 3 is 6. I'm hurting my brain now. Times 2 is 12. So you get 12a squared, and there is your final answer. So Young didn't promise you a rose garden on these videos here. These are going to be a little bit more challenging when you have to simplify first. Oh, you dirtbag, Young. Sorry. All right, let's do the cube root one. Now, if I break down the cube root of 54 and prime it, I'm going to have the cube root of 27 times 2, so that's going to be 3 cubed times 2 is 54. And then I'm just going to leave the x to the 4 and y to the 11 because y'all can see some things are going to be coming out there. So always, when you simplify the radicals first, life is good. So the 3 will go into this 3. So I see some 3's coming out. I see some x's coming out. I see some y's coming out, and simplifying right away. How many? Well, 3 goes into 3. 1 3 comes out. 1 x comes out with 1 left over here in the radicand. And how many y's? 3 goes into 11 3 times with 2 left. So we have simplified this radical. But Young, you forgot something. You forgot something. I did it on purpose. Did y'all catch it? Were you going crazy out there in viewer land? Don't leave something like this hanging. You don't know how many times I see it. And I'm going to put it in there now, that number 2. Oh, my gracious, that didn't come out of there, did it? So be very careful, as Elma Fudd would say. All right, now I'm putting powers on there, so I hope everyone sees at this stage that we're going to need to multiply to get that radical out of there. We need 3 of everything. We're going to need 2 more x's, 1 more y, and 2 more 2's. And whatever you do to the bottom, do to the top. I hope you're starting to get the hang of this, because I'm trying to give you plenty of examples to help your cause. All right, now what happens here? We get the cube root of x cubed, y cubed, 2 cubed, and we're probably going to go ahead and put that 2 out front here. So here's what we end up with. The top, number times radical, 7 times the cube root of x squared y z squared over, now I'm going to go back to my orange since I'm starting to like this orange color. I don't know why. Don't forget we've simplified this one, so we've got that 3xy cubed out front times 1 of each one of these is coming out of here. 1 2's coming out. I'm putting it first now because I know y'all don't like it there at the end. 1x comes out, 1y comes out. So putting all of that together gives us 3 times 2 is 6, x to the what power? X squared, y to the 4th, and there is your final answer. So aren't these fun ones here when you get to do all these different things? Woohoo! All right, third example. We got a 4th root. You know Young likes to give you lots of roots here. I didn't put any numbers in this. Break this into little 4th roots here, and we'll say that's the 4th root of a to the 9th power over the 4th root of b to the 8th, c to the 6th. And that's that quotient rule for radicals. It allows us to make one giant radical into 2 smaller ones, or vice versa. All right, what's coming out of the can, the radicand? 4 goes into 9, 2 a's coming out, 1 left under that 4th root. How many b's coming out? The b's make a total jailbreak. 4 goes into 8 twice. 1 c comes out of there, but oh, Young, 2 c's don't make it. So what we're going to need to do is get out from under that radical, noticing here that that is a 4th root, so we need to force how many c's under there? 4 c's. So I hope everyone sees at this stage. Do you see? You get it? Do you see how many c's? You need 2 more c's, you silly class there, and you will get the 4th root of c to the 4th power, and 1 more c is going to come out of there. So in the numerator, and again, be careful here. You could use colors just like I use colors. I love to use colors in math, and my lecture students and hybrid students will tell you that. So that way you can circle the wagons and see what you got here. And then you will have a squared times the 4th root of a to the 1st c squared. And that's good because no power under this radical here, this radicand, exceeds 4, or you know you would have messed up. Now be careful down here. I'm going back to that orange I've been using in this episode. I'm circling that. And remember, this 1c comes out here that we had. So multiplying those 2 together gives you b squared, c squared for the 3rd example. And we're almost done with this one. All right, let's do the 5th root, and we'll call this one and be done. All right, so breaking this one up and priming all the numbers, we're going to say that's the 5th root of 2 squared d to the 12th power over the 5th root of 45 would be 9 times 5, would be 3 squared times 5 to the first power, e to the 24th power. So what's coming out of the can? In the top, 2 D's come out of there. 5 goes into 12 twice. And if you want to, you can slap the colors on there. I'll go red here just to have a really cool looking video with lots of colors. So 2 D's come out. Nothing else does. So we'll go ahead and leave everything else under the 5th root here in the numerator or top. So that'll be 2 squared D squared all over. All right, what's coming out of the denominator? A whole bunch of E's. I say 5 goes into 24. And let's use a different color for this one here. Let's use a purple. 5 goes into 24 4 times. So e to the 4th comes out. This is looking very colorful now. Times the 5th root. I don't think anything else is making it out of the radical down there. 3 squared times 5 to the 1st. And I think there's 5 goes into 24 4 times. There's still 4 E's that didn't make it out. Oh, those poor E's. All right, so to get out from underneath the radical, ladies and gentlemen, and you will never see one this tough in the software. I mean, you'll probably never see this one this tough in any of the homework. I would be shocked if you did. How many more 3's, 5's, and E's are we going to need? Well, hopefully y'all say we need to get 5 of each, so 3 of them. 4 5's will give us 5 5's. And then 1 more E. And whatever you do to the bottom, you got to do to the top. And I hope I don't run off the screen here again. I didn't realize all these examples here were going to cause such a beastly problem. Holy cow. All right, so I'm going to say down here we're going to have 5 of everything. So we're going to end up with 1 3 coming out, 1 5 coming out. I'm running out of a whiteboard here. And 1 E coming out because we're going to have the 5th root of 3 5 5 5 E 5. And then don't forget, I'm going back to the orange here, this e to the 4th is already out here to combine with what comes out. Oh, Young, why do you do it to us? I'm actually going to try to, well, maybe I'll sneak this on and it will show up. And in the top, I'm gonna try to move it up just a little bit. You're going to have D squared, which is already out here, times, here comes your answer, it's a beastly one, the 5th root of, all right, 3 times 3 cubed is what? Gosh, I'm going to have to get my calculator out for this one. This is a beastie one here. Great Scott, where is my calculator? That number is going to be tremendous. Hang on just a second. Young is actually having to, in the middle of a video, stop and get his calculator. Because I don't know what 3 to the 3rd power times 5 to the 4th power times 2 squared. Well, I know 2 squared is 4 and 3 cubed is 27, but I'm going to have to go 5 raised to the 4th power is 625 times 3 cubed is 27. 16,875 times 4, oh gracious, is the 5th root of 67,500 D squared E under there, all over 15 E to the 5th power. So what a great way to finish. And I know this 5th root of 67,500 is simplified because those numbers under the radical are all less than 5. If anyone asks you out there, you'll be able to tell them, I know that since all of these numbers under here are less than 5, that simplifies. All right, so go ahead and start rationalizing those denominators, and we'll be back with the 3rd and final episode for this section. Professor Bob Young, signing off.